Dude, how do we know how far away galaxies are? Through exploding stars. What? Really? It's one of the ways. Look at this galaxy. It's 55 million light years away, meaning the speed of light took 55 million years to get to us from this. What? How do we know that? This? A star? A star that exploded, a supernova that's outshining the entire galaxy that it's in. We can use it to figure out this galaxy's distance. How? Well, there's a certain kind of star that always shines with the same brightness when it explodes, a brightness that we understand very well. And if we know how bright something in space actually is, its absolute magnitude, and compare that to how bright it appears to us on Earth, its apparent magnitude, because things appear dimmer the farther away they are, we can work out its distance with physics. So an exploding star always shines with the same brightness? That seems ridiculous. It is ridiculous, but it's true. The kind of stellar explosion we're talking about involves a white dwarf star. Ring a bell? Yeah, that's what the sun will become, right? Correct. The sun isn't massive enough to go supernova, so billions of years from now, it'll run out of fuel, shed off its outer layers, and leave behind its incredibly dense exposed core, comprised mostly of carbon and oxygen, what's known as a white dwarf. Okay. This is the fate of all low to medium mass stars. They don't explode like the high mass ones do, but as it turns out, the white dwarfs they leave behind can. Through a derivation involving quantum mechanics and special relativity, it can be determined that if enough mass or stuff was added to a white dwarf, it would go supernova. Specifically, this would happen if a white dwarf were to ever reach the critical mass of 1.4 times the mass of our sun, what's known as the Chandrasekhar limit. But white dwarfs can never reach this critical mass on their own, so left alone, they'll peacefully exist for billions of more years. What's the catch? Stars are not often left alone. Many of the stars you see in the night sky are in a binary system, two stars that orbit a common center of mass. White dwarfs are no exception. They often have a companion star, and if it gets too close, the white dwarf begins pulling material off of it, accumulating that additional mass onto itself. Oh no. Until it reaches 1.4 times the mass of the sun, at which point it violently explodes, shining as brightly as billions of suns combined. These white dwarf explosions, called Type 1a supernovae, all occur at the same Chandrasekhar limit, and therefore all shine with the same brightness. This enables us to use them as what we call standard candles, objects that allow us to measure this vast universe. Isn't nature wonderful? That is pretty damn cool.